we are back to complete the topic. So we have orbit, cycles, and alternating groups. So we are mainly going to look at the orbit. What does orbit mean? Now I want you to know that orbit is like something in a circle. Like if I start with a 1, I go to a 2, I go to 3, I go to a 4. Do I come back to a 1? If I can come back to a 1, then 1, 2, 3, 4 become a cycle, because it's like 1 gives me 2, and 2 gives me 3, and 3 gives me 4, but 4 gives me back what? Again 1. So that becomes an orbit in permutations, and I want us to see how it is done. So if I want to look at the definition 2.5, let this one be a permutation of set A. The equivalency classes in A is determined by the equivalence relations at the orbit of that. So the orbits is what I want us to look at. Example, so want to consider a permutation. I've told you already how this permutation is formed, isn't it? You have a 1, it's C, permutation value is 3, a 2, permutation value is 8, a 3, a permutation value is 6, a 4, a 7, a 5, like that. Okay, so if I want to get like the permutation of the orbit, the first orbit, I can say my orbit of 1, the permutation of 1 is what? It is a 3. What about the permutation of this 3? Are you getting that? Remember, I started with a 1. Permutation of 3 is a what? Permutation of 3 is a 6. Is that okay? Now, what about the permutation of this 6? Are you seeing that it gives me a 1? Meaning I've already gone back to what I started with. Is that okay? That's the orbit I've been talking about. Meaning that the orbit of 1 is just going to be a set. Is that okay? 3. Then now you can take on these values inside. Is that okay? Inside the permutation. So remember, this one gave me a 3, this one gave me a 6, and this one gave me a 1. So now the orbit becomes 1. Let me try to, it becomes a 1, a 3, and a 6. The inner ones 1, 3, 6. That becomes the orbit. Is that okay? Okay, if I wanted to get the orbit of 2, then you start with the 2 itself. That one of 2 gives you what? 8. Are you getting that? 8. So now get the permutation of 8. It gives you what? From here it gives you a 2. And then what about the permutation of a 2 itself? A 2 gives you 1. So this one actually it is done because I started with a 2, and again now I'm ending with a 2. So it means the orbit is already done. So it was supposed to be this one of 2 gives you what? 8. Then the one when I take for 8, it gives me what? A 2. So that one is already an orbit, meaning that the orbit of 2 it's going to be, now I told you, you come and check for the inner ones. Have this one and this, and they are only 2. So the set becomes 2, 8. So you realize that this set actually gives you the orbit. 2 gives you 8, and 8 gives you 2 when I take their permutations. So that one becomes an orbit. Like also this orbit of 1. Let me also first show you something. Have 1, 3, 6. You realize that permutation of 1 gave you a 3, that one of 3 gave you a 6, and that one of a 6 gave you a 1. So that's why it is called an orbit. It is in a circular way, it is rotating. So when you come back to 1 again, you take its permutation, you go to 3, you go to 6 again, you come back to 1. So are you seeing that it's becoming an orbit, a circle? Yeah, so that's what we mean. So if I wanted to get the orbit of 4, this one gives you, so you have to first find the this one of 4, it gives you what? 7. Then now get that one of 7 itself. 7 gives you what? 5. Then get that one of 5, gives you what? 4. Have I come back here? Have come back where I started from. I started with the 4, gave me 7. 7 gave me 5. Then 5 gave me 4. And then I'm coming back now where I started from. That means my orbit of 4 is going to be the inner ones. 4, 7, and 5. So I have the set of 4, 7, and 5. And then you write them in that order, because the 4 is the one which gives you 7, 7 gives you 5, and 5 gives you back 4. Are you getting that? So that means it becomes an orbit. So don't try to arrange them to say that maybe this one can be written as this, maybe 4, 5, 7. Then you are going to you have interchanged the orbit, because the 4 doesn't give you 5, and 5 doesn't give you 7, and 7 doesn't give you 1. 4. So meaning this is not an orbit. Is that okay? The orbit is this. Hope you have understood the orbit thing. So whenever you get the orbits, we are going to see that these orbits help us to express these permutations in terms of something. Like if I have 1, 3, 6, that was the first one. Then I have another one, 2, 8. Then I have another one. It has been what? The one for 4. The one for 4, if we are to recall, it was 4,